In part 2 of chapter 4, we will skim this topic called graphs. As we see in this figure here, a graph is a data structure that represents a network that connects a collection of nodes called vertices, and their connections are called edges. So these nodes, the A, B, C, D, E, F, G, are all nodes, and they are called vertices. And these lines that connects them, they are called edges. The edges can have weights and sometimes are not weighted. And the edge can be seen as a path between two nodes. These edges can be either directed or indirected. Directed means you can move in one direction. If it's not directed, you can move in both directions. Graph algorithms. We have few algorithms that we will skim now. We'll go through them really quick. The first one called depth first search. Depth first search, DFS, as seen here in this graph. So this is the empty one. The DFS is just like this: depth first search or first traverse. The DFS algorithm, we start from a starting point like 0 here and go into depth into the graph until we reach a dead end, then move up to parent nodes, backtrack, like go from 0 to 1 to 4 to 7, then go up back to 5 to 2 and to 7 to 3. In DFS, we use stack. What memory we use? We use the stack pointer to get to the next vertex to start a search. Alternatively, we can use recursion or system stack to do the same. The second search algorithm used with the graphs is called breadth first search, BFS, just like here in this graph. So we start from here, we go to all of them all together. Whoever reaches the destination, then we achieve the goal, just like that. So we see the from 0 to 1, then 0 to 2, then 0 to 3, then from 1 to 4, 2 to 5, 3 to 6, 4 to 7, achieve the goal, and that's it. All right. So this is BFS. In BFS algorithm, a graph is traversed in a layer by layer fashion. Like this 0 node goes to 1 and to 2 and to 3, to the first layer. Then we go to the 1 to 4, 2 to 5, 3 to 6, second layer by layer fashion. The graph is traversed closer to the starting point. The queue is used to implement BFS. We use a queue. First in, first out. Okay. Sorting algorithms. So we sort things either in ascending or descending orders. Why? Because the searching becomes easier when they are sorted. All right. So there is a sort function that can be called, and it will, the time complexity is a function of n, which is the log, the number of elements, times log n, and that's a fraction, right? So it's not really long. Counting sort. Another type is we have the counts. So we have the count of each data type. So we have the 1 here, and this is 3, count to 3. So it's repeated 3 times, just like here down there. And we have the 2, and the count is 1, so just 1 times 2. The 3 is 0, so we just eliminate that. The 4 is 2, so we just put 2 4s, and the 1 again is 5, so the 5 is 1 time. Sorry. The 6 is twice. The 7 is 0, the 8 is 1s, the 9 is 0. So this is the sorted output. If we know the range of input, so for that, let's read this. Counting sort is the simplest and most efficient type of sorting. So it's the most efficient type. Counting sort has strict requirement of a predefined range of data. Like sort how many people, so this is an example, are in which age group. We know that the age of people can vary from 1 and 130. All right. If we know the range of input, then sorting can be done using counting and time complexity, a function of n plus k. K is the count, the number of counts, and the n is the number of elements. All right. And here is the end note of chapter 4, and it says this chapter has provided a brief, so very brief. And we went through it really brief because our goal is to skim or browse really quick this book. This chapter has provided a brief introduction of the various data structures, algorithms, and their complexities. In the coming chapters, we will look into all these data structures in details. If you know the interface of the various data structures, then you can use them while solving other problems without knowing the internal details, how they are implemented. And next we will start chapter 5 in the next video.